Really? To sleep.
C by some particular.
Now we have to use a result actually. Okay, the result is that if you have this thing, then it should be same as C times of Riemann of f of x, like that. Xi
Minus 1.
have you seen such kind of result? So it's like Riemann of some number multiplied by a set is same as
C times
that number multiplied by the supremum of. Okay. For an exercise actually. So if this is the case, then what does this come? This is C times mi. And similarly, I can show that MIC is C times sum. Okay. So if this is the case, then UCF FP alpha minus L CF P alpha should be equal to what? Sum of MIC minus MIC times delta alpha I, where I runs from 1 to L.
C go by there.
And that's what you can do actually. So C times of, so it's like a C times of UFP alpha minus
C times.
LF alpha. So
It's not by C.
It's not by
yes.
It's just.
Lies that this CF belongs to. What is the next thing? So we need to, not some basically, we need to prove that identity. We have to prove the identity. The integral of A to B CF C alpha is equal to what? So it's equal to the lower integral and upper integral. So if it is equal to the lower integral, for example, so it should be equal to what? So I'm saying that this is equal to A to B F E alpha.
C.
So it should be equal to what? Sum I equal to 1 to n
Of C times MI.
MIC delta alpha I. So I can pull out C outside. So I'm going to have I equal to 1 to L mi delta alpha I. And this is equal to what? C times of the lower integral A to B F D alpha.
Which is
But
same
since
as
F is integrable,
So it is equal
so
to
this lower integral should be equal to what?
the integral.
It's like a precise argument, not just avoid by. Precise argument, proving everything. You can't see that? Not at all.
give it up to that.
You see, it looks something very simple. Okay, let's pull out C outside. Pulling, you have to do all that. All this is happening at the back end. Okay? So let's move now to the second part. Now, the second part of this sum. So y f1 plus f2 should belong to R of alpha when f1 and f2. So we have to do simple. Given epsilon positive, since f1 and f2 are integrable, for them we can find partitions. There exists partition P1 and P2 of A comma E such that use f1 P1 of alpha minus L f P1 of alpha is smaller than epsilon L modified to final quadrant. And P2 alpha minus L of f in alpha is less than epsilon. Okay? So what I'm interested in, what would be the difference to u f1 plus f2
Minus.
minus f1. But we need to find a partition. What should be the partition? So obviously the natural choice would be choose refinement that choose P to be P1 union. But my claim is that this is going to work. Okay. Why this is going to work?
सर मेरे ख्याल में एप्सिलॉन बाय 2 भी करना पड़ेगा शायद.
Okay, so what would be okay, so what would be sum of f1 plus f2 d alpha? I know that this must be
From
UFP alpha. FP is f1 plus f2.
that is sense.
Define the
One man.
define the entropy of one process.
Okay. So let's set F to be F1 plus and F d alpha from A to B. So we agree that it should be smaller than or equal to UF alpha. Why?
Any partition. Because it's true for any partition.
So that's its infimum actually. So that's an infimum of UFP alpha. It should be less than or equal to this. Now, if this is the case, then my claim is that this guy must be less than. Let's rewrite this again. You know the line that we wrote before. First, what was the key inequality that we had in the first proof? The first inequality. So we have this actually. Imagine if I have LFP1 alpha, it should be less than or equal to UF P star alpha less than or equal to P star but P here. Obviously, E is because it is P2, agreed? And this must be less than or equal to Now, say that this is smaller than or equal to f, f p alpha, and this is less than or equal to u f p2 alpha. Agree?
The first week given
Why not? Lower sum
of
for any two partitions.
it's P1.
So that's P1 and that's the refinement act.
Yes, sir.
So lower sum is going to be this. And then it is going to be less. Okay. So my claim is just incorporating these two inequalities. Okay. I have epsilon by 2 and epsilon by 2 and this inequality. Like, let's call this 1, 2, and
वहाँ पर फिर पीठ से नहीं होता ना
कहाँ पर?
लोअर का
ठीक है।
What refinement?
No, that's just a common refinement. That's a common refinement. So my claim is that using inequality 1 and 2 and 3, I can find an estimate on this integral f, and that estimate is going to be less than what?
Very good.
So that's the integral of a to b f b alpha, that is f1 b alpha plus integral from a to b f2 b alpha and plus epsilon. Okay? How is going to happen? That's what you have to figure out for yourself. Now, if this is the case, then we are almost done. Why? Because what we showed is that the difference between f d alpha and sum of these two individual integrals it will be f2 d alpha is less than epsilon. Okay? It's less than epsilon. So if this is less than an arbitrary epsilon, we're going to say that both are equal.
बहुत सारे बेटर सर
So, okay, how are you going to get this actually? So I can relate the UFP1 alpha with the integrals. Now, it's going to be the same trick that we said. So try to figure it out for yourself that why this should be true. Okay? Right? B. Yeah. The integral is monotonic. In other words, if a function is less than or equal to other function on the interval, then the integrals is also. So I'll not prove that directly. I'll prove it indirectly. In other words, I'm going to prove this if h is bigger than or equal to 0. In other words, if f is bigger than or equal to 0 on a to b, then integral of a to b f d alpha is also bigger than or equal to
फिर वो डिफरेंस पे
a. So the result that we want is going to be the corollary of this.
of course
Just take f to be the difference of.
difference
Now why this should be non-negative? Just think about it. A to b f d alpha. This is equal to what?
कोई एक बार सम करे
So this is equal to, since f is integrable, so this is equal to lower integral. For example, it is equal to what? Sum of mi where I equal to 1 to n delta alpha I. Okay? So delta alpha I is always non-negative. Why? Because alpha is monotonic. So there is no trouble with it. So the only thing that we have to take care of is mi.
Here we say monotonic means increasing.
Monotonic and increasing.
Right.
Now think about mi. Mi is what? It's a supremum of f of x such that x
Of some images,
is
All images are positive, but
is positive.
x I minus 1. Okay. This must be. So this is non-negative.
Yes.
Then this is above by this follows of. Okay. And then try to argue for the difference for yourself. Okay.
F minus G.
Yes.
सर डायरेक्ट यूज कर सकते हैं ना हम लोग हाँ मतलब अगर एक दूसरा एक बटा है दूसरे से तो उनका अपर सम भी इस तरह से पढ़े होंगे लोअर सम भी
I mean, it's completely up to you. It is important to do through this trick actually, because that's going to repeat this type of argumentation that whenever you want to prove this kind of inequality, the better is to just take that and think about the non-negative case and the monotonicity is going to follow. Okay. Okay, Rudin.
That's it.
Just going to give you some French phrases. I mean, if you want to see arguments in detail, for example, for which I have kind of done shortcut, you can see it from Slavin. But the Slavin only deals with the Riemann integral. It doesn't talk about Riemann Stieltjes integral. But argument could be developed, really analog. There is no difference between the argument of almost Riemann integral and Stieltjes integral because it's almost the same thing. Now, so we'll do part C next class because that requires a detailed proof. So I'm going to just quickly browse through part D and E. So part D was what? Part D was that if f of x is less than or equal to, it's a bounded function, then the integral, absolute of the integral f of x dx must be between what? Between m times of
Alpha.
f of t minus
Alpha.
sorry, alpha of t minus alpha of b minus alpha of a. Okay. This should be the case. What do you think? Why this should be? I'm saying that it's just a corollary of the result that we just proved with the part C. Think about it. You know, what does this guy is giving you? This is giving you that f of x is between minus m and okay. Then what should we do?
Integrals will also be.
Just integrate. Because we know that minus m is less than or equal to f of x. So its integral of this is going to be smaller than or equal to integral of this. And the integral of this is going to be smaller than this. In other words, integral m d alpha of a to b should be less than or equal to integral a to b f d alpha less than or equal to integral a to b m d alpha. Okay. This is a number, we just proved it. I can pull it out of integral. Minus this times alpha of b minus alpha of a less than or equal to a to b f d alpha and less than or equal to m times of alpha of b minus alpha of a. Gives you what you want. So, the last part P, that's A to B, that's D alpha 1 plus alpha 2. So, what should be the definition? Okay, maybe the first thing is that does this make sense actually in the first place? Is there something like this guy?
Beta is equal to
Does this exist?
beta power.
So we know that this makes sense. So in order to make this sense, what we need to do, you need to think about you have P of alpha 1 plus alpha 2 minus LF P of alpha 1 plus alpha 2. See? That's what you have to think of. But this would be what? This would be sum of I equal to 1. Okay? F mi and delta of
Alpha 1 plus.
okay, so it's like alpha 1 I plus alpha 2 I. Agree?
Sometimes.
So I like that minus I can directly write that this is going to be mi minus. Okay. Now think about this guy. So what is delta of alpha 1 I plus alpha 2 I? So this should be alpha 1 of I plus alpha 2 of I evaluated at x r. See? Minus this would be alpha 1 of I plus alpha 2 of I evaluated at xi minus 1. Okay. And then what will be this difference? So I can say that this is same as alpha 1 I of xi plus alpha 2 I. Oh, भाई को समझ आ रही है? What's going on? Minus alpha 1 I of xi minus 1 and minus alpha 2 I of xi minus 1. And as per expected, you can combine these both. In other words, this is going to be delta alpha I1 plus delta alpha I. Okay, 2I, whatever you write it. Okay. So if this is the case, what's going to happen? So this sum is going to be simplified to sum of mi minus capital Mi times delta alpha I1 plus sum of mi minus mi delta alpha I2. And my claim is this is nothing but, you have to be careful. What will be this difference?
इंटीग्रल होगा ना सर
Just be careful that would that be a to b f d alpha 1 plus a to b. I'm not sure. Just think about it. If this is the case, we are done, but you need to think about justifying it, that why this should be. Anyway, so that's it for today. Okay, go around, rewrite the proofs. These are fun proofs. Okay. We're going to finish.